Uh,
Working these out, just have a little chunk on over there. I'm writing without talking to you right now so that if you're working it on your own and you get into a point where you're jammed up, look on the board and I've got a little bit of information that'll help you. If anyone finds the two X values, let me know. Think you got them? 13 and 1. We'll see if you're right. Someone's going to tell you you're not. Work out your X values. If you run into a jam, take a look at the board. Kind of give me a nod or raise your hand once you get to the X values. If the X values okay? Back row, y'all got the X values already? All right. I realize there's another point that's going to be tangent way down there, right? I think it turns out to be pretty far down there because it's going to have to go out. So that point is negative. I got 140 what? 142. I'm trusting you. 13 comma negative 142.
Oh, no, I didn't multiply it by 2 yet, so it's not.
Oh, okay. If you look back, it's going to be recorded. 13 squared is 169, right? 27 minus 2 times 169. So 27 minus 18, 113. 338.
I got negative.
3 something?
Yeah, I got negative 311.
3, that's what I'm getting.
Yeah.
Negative 311. Aren't you glad I let you leave them just in the point slope form? And then what's the slope? Now here's something I want to talk to you about, folks. Once you know that that 13 is on the graph, it's on the curve, you can use the calculus slope. Okay, negative 42. But you have to have a point where, in order to use the calculus slope formula, you have to have an x value that's where? On the curve.
Wouldn't it be 52?
Sure would. I'm trusting you. Negative 52. There you go. And then you can write the two equations. Now, all of this work has brought us, if you look at the assignments. Oh, I've got something else I got to tell you before we look at the assignments. Everybody okay up to this point? I don't want to erase this in a hurry. I want to make sure you can see it. While you're looking at that, I can go over here and get us up to date over here. Make sure you're happy. If you got a question, ask me, and I will try to help you. Don't tell me that's wrong. And y'all know to actually see, oh, well, you can see it if you look in the instantaneous rate of change in tangent lines. And I gave y'all this assignment the other day. I put it on the computer last night, I think, or it probably tells you what I put on the computer. But it's got it listed here, and it says module L 3.3a and L 3.3b. L is the light hole book. I don't have to write out light hole every time. So the light hole book is the L. And if you'll notice, the only thing new is number 45. Okay? I'd already given y'all all the other stuff, but I gave you 45 with it. And here's the whole catch. 45 is that. 45 is the Pofc problem. I think all the other problems in that assignment are Pofcs. Okay? And this is all about tangent lines and all that. Now, if you look, I'm going to go ahead and put on the modules here for light hold. I just went ahead and did a module for light hold. Okay, L 3.3, there's your modules. And if you click on that, here's a problem I ran into. Other than the fact that they're on the side of the page. Okay, yeah, we'll look this one right here. Okay. Is everyone finished with the problem up there? Is there any question about the problem at the front? Anyone? Give you one more chance to look at it. Okay. See this little dx right here? Okay? Or see the little d over dx? That's the rules I've been teaching you. The rules I've been teaching you are called derivatives. Okay? But here's the problem that you run into. I have students that will say, I took the derivative, but they don't know what the derivative is. Everybody say it. The derivative is the formula for instantaneous rate of change or tangent lines, slopes. The derivative is the formula that finds you what? Tangent line slopes. Say it. The derivative is the formula that finds tangent line slopes. So I've been avoiding using that word. I've been using the word instantaneous rate of change and tangent line so that you would know what the word means. When you say derivative, you get kids that go, oh, I take the derivative, but they don't know what the derivative is. All right? The derivative is measuring an instantaneous rate of change, or it's measuring a what? Slope of a tangent line. of times when we use the derivative later on, if the derivative is positive, that means my graph's going up because the slope of the tangent line has to be what? Positive. Derivative is negative, that means my graph is decreasing because it would have to have a negative tangent slope. So you've got to know what the word derivative means. The word derivative is talking about slopes of a tangent line or instantaneous rate of change. But when you see that notation, dx, gosh, I hate to erase that. It looks so pretty. Probably don't even need to work an example of this because you've already know how to do it. But when you see that notation, we'll do 26 up there. dx, how do you write D? He did the big dx version. And he's saying, what he's saying is take the derivative of this. X plus 3. So, what I do, go right under there. And remember, quotient rule, quotient rule. You write the denominator down and you put a square above it. You square it. Then you write the denominator down and you take the derivative of the numerator. That's that n prime. That little prime symbol meant take the derivative. I told you use the first rule, which is take the derivative. 2 minus, write the numerator down. When you take the derivative of the x, is everybody okay? You're just going to get a value of 1. Okay? Now, somebody says, do you have to put that 1 there? You don't, but it sure does. It sure does make life easier for me if you put the 1 there. Okay, you're about to tell me I wrote something down wrong, because I did, didn't I?
The 2x is supposed to be the denominator.
Yeah.
Okay.
Denominator, derivative of the numerator.
2x is the numerator.
And then it should be numerator times what? Derivative of the denominator,
it's
right?
Still the numerator.
Instead of 2x, it's supposed to be x plus 3.
Oh. Just turn the camera off and erase this one. Whew. X plus 3, write down the denominator, derivative of the numerator 2, minus the numerator 2x times derivative of the denominator 1. That's what happens when you teach too many classes in a row without any breaks. Sorry about that, guys. Thanks for looking at me and telling me. Yeah, notice what I had to go back and do? I had to put the little notation up there. D, N, yeah, I did that on purpose. I'm laughing behind the mask. All right, but that's how you work with those. Now, what I suggest, and I don't know how much you've done, but I suggest if you've had trouble finishing up the Stewart, jump over to the light hole problems. All right? Jump over to the light hole problems if you've been having trouble doing the Stewarts. And if you look, I think if you go to the next page of this, if I can find out how to go to the next page. I'll go ahead.
If you go down, you probably should hit next.
Just go down to the bottom where it says, right there, next. And the B page must be the second half of it. You know, it's what it is. B page is the second half. Your connection's not. I don't understand why I would say that. I promise you it worked yesterday when I put it in there. The school system doesn't like that page. I don't know why. All right, but when you go to that page, and I probably need one of y'all to check, make sure you can for it. Tell you what, let's just go through the modules and see. Do it this way and see if it'll let us see it. I don't know why it wouldn't since I. don't know. Someone check it on your phone or check it and see if it lets you get there. It works for yours?
Yes.
Okay, good deal. It worked for me yesterday, and what I've been doing is I've been putting all this on at home with the school computer, and then I've been just checking it with my home computer to make sure it really comes out the way it's supposed to, because this is all new to me. But that'll get us to that point. On Wednesday, I haven't decided if I want to do trig derivatives or if I want to do an application of what we've already learned. And I'll just let you know Wednesday on that. Okay? So what you've got, you really only have one new problem.